This next mini lecture is on assigning stereochemistry. So we've got an example here. I alluded to this earlier when I went through the introduction. I'm going to go into it in a lot more detail here. So let's say we've got a compound, and here's our compound. We've got a carbon. It's clearly got 4 different things attached to it, so it's definitely subject to stereochemistry. Now the point of this is to figure out which stereoisomer it actually happens to be. Is it R or is it S? Now the way we can do that is to first of all assign priorities to each of these groups, and the assignment of priorities works the same way as it did when we talked about the EZ system with the alkenes. Now the idea is that we've got the carbon, and to each of these we've got an atom attached. Now we're interested in just the atom directly attached to the central carbon atom. In this instance we've got an O, an H, a C and an N. And what we do is we prioritize these based on their atomic weight. So oxygen is first, nitrogen is second, carbon is third, and hydrogen is last. 1, 2, 3, 4, that's what we've got. Now none of this matters unless we look at the 1, 2 and 3 with the lowest priority group in the back of the compound. So what we do here is we keep the methyl group still, that's this group here, and we rotate these groups around so that the hydrogen ends up going into the back. So the H will move here, the OH will move up here, and the NH2 will move down here where the H is. So there you go, there's the H, there's the OH, and there's the NH2. Everything has basically just moved around one space, while this has remained the same. Think of this as being like an airplane propeller. Now that the lowest priority group is in the back, we are allowed to look at the order of the 1, 2 and 3 groups. The 4 group gets completely ignored at this point. But as you can see, we've got the 1 here, the 2 is down here, and the 3 is over here. And they go in a clockwise order. 1, 2, 3 goes clockwise, and that then gets assigned the letter R. R for rectus, which means to the right. So that's because the priorities go towards the right, so that's clockwise. This would be called R1 aminoethanol. Alright, let me give you another example. Let's pretend I gave you 2-bromobutane and I asked you to draw the stereoisomers and assign the stereoisomers of that compound. Alright, I'm going to do this on a page here. Right, here's our compound, 2-bromobutane. First of all, I want you to look at the compound and be convinced that the only chiral carbon in this compound is the carbon that I'm pointing at here. Now the reason I say that is because if you look at this carbon, that's going to be a CH3, so that can't be chiral. The only way that a carbon can be chiral is if it has 4 different things attached to it. This particular one has 2 hydrogens the same, this one has an H, a Br, and a CH3, and a CH2CH3. I'll draw the hydrogen in here as well. So you can see that this particular carbon is chiral because it's got 4 different things attached to it. Now our next mission is to draw both isomers of that compound. So what we'll do is we'll get smart about this and we will draw an isomer that has the hydrogen already in the back. Because remember, when we're doing the RS system, that's what we're going to do anyway, is try and get that hydrogen into the lowest priority position. It's going to always be the lowest priority, so it's going to have to end up being in the back. Alright, so let's assign priorities to this now, knowing the hydrogen is always going to be 4 because it's always got the lowest atomic mass, so it goes in the back. So let's look at the priorities. This will be priority 1. Now this one will be, it's now between these two here. So we've got a carbon and we've got a carbon. So we haven't got a winner yet. We can't discern between those two. So remember what we do with the priorities. We go out to the next atom, and the next atom here is a hydrogen, and the next atom here is a carbon. So what that means is that this group is going to be the winner, and that's going to be 2, and that's going to be 3. Now since we've already got the 4 group in the back, we're going to ignore that, and we're going to look at the order of the 1, 2, 3 here, and here's what we notice. It goes 1, 2, 3, and that's clockwise, so that is going to be R. This compound would be called R2-bromobutane. There's a couple of ways that we can work on to get the S isomer of this compound, and there's two ways that the two ways I like to use. The first way is just finding the mirror image of the compound. If we get the mirror image, we're going to automatically get the other isomer. Alright, so there's our compound. Here's a mirror. Let's get the mirror image. I don't even have to check this. I know it's going to be S, because whenever you take the mirror image of any chiral compound, you always come up with its enantiomer. And the enantiomer in this case has the opposite stereochemistry. That's one word there. So it's S2-bromobutane. You don't believe me? Here, let me show you. That'll be 1, that'll be 2, that'll be 3. Now, what do you know? Counterclockwise, so that would go S. The other way that you can get a stereoisomer, I'll take the original compound here, we know is R, is I can simply switch any two groups on this chiral center. So if I do this, just switch the H and the Br, I know I'm going to have S. Now I know what you're saying. You're saying, well, hang on. Now the hydrogen isn't in the back. How do you know it's S? Well, I'm just telling you that whenever you switch any two groups on any chiral compound, you can automatically be assured that you have switched its stereochemistry. I know that I can't tell by looking at it now that it's S, but you can be assured that it would be S. The way I could check this is by rotating the hydrogen into the back again. So let's do that. Right, so now the hydrogen is in the back again. The bromine is now going to be up here, and the methyl group is now going to be in the front. So if I find the I find the priorities, that'll be 1, that'll be 2, this will be 3, and indeed it is S, counterclockwise 1, 2, 3.